It gave you cosecant theta equals 25/7, and then it gave you tan theta equals 7/24. That's what you use to draw your right triangle. Pick any angle. I just always pick the bottom one. So you could pick the one on the top. It doesn't matter. I know that tangent is opposite over adjacent. So your opposite is 7. Your adjacent is 24. Cosecant matches with sine is opposite over hypotenuse. So cosecant would be hypotenuse over opposite. So our hypotenuse is 25. If you worked that out, you'd still get 25 if you did that. Okay. This one was the easiest one because they're whole numbers and it's already set up for you. Like you didn't have to do any work on it. So then we want to find all of our trig functions. So we have sine, cosine, tangent. Sine is opposite over hypotenuse. What's your opposite? 7. What's your hypotenuse? Cosine is adjacent over hypotenuse. Adjacent is? Hypotenuse is? Tangent is opposite over adjacent. They already gave it to us. Then remember, you're going to switch them. Cosecant, secant, and cotan. You're just going to flip them over. So cosecant, 25/7. Secant is? And cotan. So once you get the first one, the second one's really easy. I'm going to go ahead and do number 10 because it looks weird. So this might have thrown you off.
I think Zoe Nance, we're good, neon,
What did he just say?
to the commentary.
Is what?
Rubens?
We quit. I didn't know. I had no idea what, no, I had her last semester, but I didn't know what he said. Like, what are you like trying? Ooh. That was rough. I know. Could you imagine having like that? Whatever her name is, what her name is, but could you imagine having that and everybody butchering that all the time? It would just be crazy.
Her older sister's Grace.
That's not her first name though.
I know. But she goes by Grace.
I don't think that's her first name. I think she goes by Grace. Doesn't matter. All right, look. So down here, when we have sign of a negative number, that means it's going to be the negative sign. So the positive sign would be a positive 1/3. They also gave you that tan x was negative square root of 2/4. Sorry, y'all. So if we have our triangle, sine is opposite over hypotenuse. So our opposite was 1. Our hypotenuse was 3. How do we get that bottom number? And tangent's not really going to work for us because it doesn't look like the 3 or the 1. So it kind of would make you, think about it a minute. How do I get the bottom number? Yeah. So anytime I have the hypotenuse, I'm lazy. I'll do 3 squared minus 1 squared. You can see I did it earlier today. That's not what I meant to do. 3 squared minus 1 squared, which gives me 8. So this is the square root of 8, but this is not simplified. Okay. Your factors of 8 are 2, 2, and 2. You're looking for pairs because it's a square root. So I had 1 pair of 2s that I'm going to pull out. And I left a 2 on the inside. So 2 square root 2. Now that I have my triangle, the only thing I need to worry about are my signs. So if we go back to this little chart right here, okay, where is sine positive, but tangent negative? Quadrant 2. So we are in quadrant 2. That means sine, cosine, tangent. Sine is positive, negative, negative. So that way we'll know what our signs are. What is cosine? What's your ratio for cosine? So our adjacent on this one is Positive or negative, it's cosine. Negative. That's all you do. Tangent. We already know it's what? Okay, so don't do any work on that if you don't have to. Why does it look like this? Because you have this one on the bottom and then you have to rationalize. So just leave it because they gave it to you, but we'll have to do that eventually. Cosecant, what would it be? 3/1 or just 3? Secant. -3/2 square root 2, doesn't matter where you put the negative, but we can have a square root on the bottom. You don't have to multiply that by 2 on the outside, just the square root of 2, which gives us -3 square root of 2 over 4. And then cotan, you would have 4 over the square root of 2. It's going to be negative. Multiply by the square root of 2. You get -4 square root of 2 over 2, which changes to -2 square root of 2. Number 12 is basically the same exact way. Okay. Any questions, 8 and 10? 12 is pretty much the same way. You got to figure out what quadrant it's in based on what they give you and then work on that triangle. All right, what about 15 through 20? Everybody was good with those? Okay. 15 through 20.
Oh, yeah.
Everybody was good with those? Did you do them?
I did them. I don't know how to do it.
Did you do them correctly?
Probably not.
What do we get for 15?
1.
What letter would that be? C. Let me go through that. Let me go through the letters and then, because 15, you could look in the back of the book for, but let me go through the letters and see if you got them. And if we don't, then we'll work on them. What about 16? Louder. B as in boy. 17? F. Any questions on those? 18? A. 19? E and 20. Anybody have any questions on those now? All right. 22, any of the 20s, 22, 24, 26, or 28? Any other ones? Just 26? Okay. All right, 26 was secant 4x or secant x to the 4th minus tan x to the 4th. This would be the same thing as x to the 4th minus y to the 4th. How would I factor that? What if I had this x squared minus 4? X plus 2 and x minus 2. So we split them in half, right? So what would this one be? Okay, but we don't have x and y. What do we have? So secant squared x minus tan squared x and secant squared x plus tan squared x. What do you notice from here? I have secant squared x minus tan squared x. So here's secant squared x. What do I have if I subtract tan squared x? 1. So this turns into 1 times secant squared x plus tan squared x. There's absolutely no rule for that. So that's your final answer right there. What about 28? Is everybody okay with that one? Everybody did great on 28.
Need all ninth graders, current ninth graders' last name beginning with letter P and Q. Please head to the Collins area. All ninth graders' last name P and Q. Please head to the Collins area.
30, 32, or 34? Everybody, say it again.
34.
2 cosecant x plus 2 and 2 cosecant x minus 2. What do you notice about the factors? Yeah, they're opposite signs. They're the same. So what do we have to multiply? Beginning and the end. 2 times 2 is cosecant times cosecant is cosecant squared. And then the ends, 2 times -2, -4. What can I do to these? Take out a 4. I see that cosecant squared. If I subtract 1, cosecant squared minus 1, it's going to give you what? Cotan. So this is 4 cotan squared x. That's it.
Okay.
36 or 38? Got it. Everybody good? 36 and 38? Yeah. Do you need it? Okay, just tell me. No worries. Y'all, seriously, if I had to do every problem, I would be okay doing that because trig functions are not super easy. The more we do them, the easier they get. So seeing them is not going to hurt us. First of all, we have 6 minutes between classes. Second, you walked in late. In between classes. What's your time? Go ahead and go, but this is every day. 38. Cosine t, 1 plus tan squared t. Look back, I see that tan squared t plus 1 is secant squared. So I have cosine t times secant squared t. What is secant squared? What is secant? Oh. So we actually have 1 over cosine squared t. What do you notice? One of the cosines will cancel out. Now we're left with 1 over cosine t. What is 1 over cosine t? What's that? $40. Everybody good with 40? 42. Yeah, I figured that would be it. So 42, when I told you, like, when you do work, if you had it as X's and Y's, you probably wouldn't have a problem with it. Okay, but because it's sine and cosine and all that crazy stuff, that's why. So we have cosine squared y over 1 minus sine y. There's absolutely nothing I can fix. So I need to fix the bottom. How do I fix this bottom? How do I fix the bottom? Multiply it by the conjugate. 1 plus sine y over 1 plus sine y. On the top, distribute your cosine squared. So you get cosine squared y plus cosine squared y sine y. How do I multiply the bottom? Just the outsides. So I get 1 minus sine squared y. Tell me what you think I should look at. At the bottom, because it has a 1 and a squared sign, right? So that should trigger you that maybe it's a Pythagorean identity. So let's go look at it. So this one says 1 minus sine squared y. So right here, if I subtract sine squared, what do I get? A positive cosine squared. So on the top, same thing that we had before. But on the bottom, we're going to change it to cosine squared y. What do you notice?
Well,
They cancel out because all three terms. Does everybody understand that? All three terms have cosine squared. So this cosine squared will cancel out to 1. This one will cancel out to just have sine y. And then the bottom will cancel out completely. That's your final answer. Anybody 44? $46? Okay. All right, so 46. 1 over secant x plus 1 minus 1 over secant x minus 1. We did one like this in our notes. How do we get them together? Cross multiply and then squish the bottoms together. So cross multiply, squish the bottoms together. 1 times secant x. 1 times negative 1. Negative 1 times secant x. And negative 1 times negative 1. I mean, sorry, negative 1 times positive 1. On the bottom, what do I multiply? What do you notice? They're conjugates, so just the first and the last, right? So secant squared x minus 1. Tell me some things that happen. Yeah, we have a positive secant x and a negative secant x. You could put the negative ones together, which will give you -2. What do you notice about the bottom? It's a square and a 1, right? So that should trigger, okay, maybe it's a Pythagorean identity. So let's look for secant squared x. It's a -1, which will give you tan squared. Yep, you will. Then they don't like tan squared on the bottom. So what is 1 over tan squared? Cotan. So the final answer is -2 cotan squared x. We do not want a fraction. 48. Yes, no, maybe. What'd you get for 48? Louder. Good. Anybody need to see that? All right. 50. All right. All right, so 50 was 5 over tan x plus secant x. How do I fix it? It's just like 42. Notice it's just like 42. What I have to do? Multiply by the conjugate, tan x minus secant x, tan x minus secant x. You can distribute your 5 or just stick it together. It doesn't matter. On the bottom, what are you going to multiply? The first and the last, yeah, they're the same. So except for signs. Tan x times tan x. Tan squared x. Secant x times negative secant x. Already. If I have, watch this, think about it in your head. Tan squared x, and I subtract secant. What am I gonna have to do with 1? Subtract over, so what's it equal? -1. Oh, tan x minus secant x. Okay, so it's just -1. And I put it with a 5. Now, sometimes they'll change all the signs and flip it around. So if I make the 5 positive, the secant will become positive and you'll subtract tan x. I'm good with this answer. This is not a problem for me. This is the book answer that they would have given you. So this will be like your multiple choice. Don't worry about it. Like sign wise, just change all the signs. 54 and 58. Sorry. Really? Oh, these are easy. I could see 58 more than 54. You did these at the end of your notes. That's not me being mean. They're like really not that hard. So once you see one, you might be like, oh, okay, I got you. And I told you that x was 7 sine theta. So you're plugging that in. What is 7 squared?
49.
So we're gonna square this. And then what's sine theta squared? Sine squared theta. What do you notice about both of them? They have a 49. We're gonna pull that out. We're left with 1 minus sine squared theta. 1 and sine squared theta. If I subtract it over, what do I get? Cosine squared. Square root of 49. Square root of cosine squared. That's it. $58 is pretty much the same way. I'm gonna get a different sheet of papers. Everybody got this one? All right, if you can't see it, I'll move it in just a second. This one gives you a full equation, -5 square root of 3 equals the square root of 100 minus x squared. So this half over here, this right side is exactly what we just did. They give you that x equals 10 cosine theta. So I'm just gonna work on that side for a minute. So just keep rewriting this one. 100 minus square this, what do I get? Ten squared is 100, cosine theta squared is cosine squared theta. What do you notice about them? They both have what? Yep, just like the last one, they both have 100. Now it's 1 minus cosine squared theta. 1 minus cosine squared theta is going to give us sine squared theta. So we get -5 square root of 3 equals the square root of 100 sine squared theta. Still cleaning that other side. What's the square root of 100? Square root of sine squared theta. It asks you to find sine theta and then cosine theta. So how do I find sine theta right here? Divide by 10. Do regular problems, guys. It's not anything any different. Reduce it, and what do I get? So there's your sine. How would I be able to get my cosine if I just have sine? Do what? Yeah, that's exactly what you do. Perfect. So again, I just pick the bottom angle every time. Sine is opposite over hypotenuse. How do I figure out my other side? So 2 squared, your hypotenuse, minus the square root of 3 squared gives me 1. What's the square root of 1? 1. So cosine is adjacent over hypotenuse. That's it. There you go. All right. If you are finished with that homework, go ahead and make sure you put it in the box and then get your 5-2 notes out.
Jones.
Yeah.
Not pleased with that.
Yeah.
What?
Okay.
I was making sure.
I mean, y'all need to start going during your own time. All right, 5-2. Verifying trig identities.
Current ninth graders, last name beginning with R, please go to
Didn't
Collins
even
area.
beat before.
Current ninth
Didn't it
graders,
only
last
beat
name
before?
R, should come
Did
there.
it even beat? I didn't hear it. They are calling them in groups. Because there's only like 4 or 5 registering. So if they send A through H, that's 50 to 100 kids. You can't do, yeah, you can't do that. So they're doing it in little groups. Does that make sense?
The freshman
Yeah.
class is also the biggest.
Yeah.
Yeah. They're, a little fella.
All right. Remember that a conditional equation is an equation that is true for only some of the values in its domain. For example, the conditional equation sin x equals 0 is only true for x equals n pi. That means that every whole pi, 1 pi, 2 pi, 3 pi, 4 pi, sine crosses the x-axis. Remember, it looks like a wave. Yes. So at every whole pi, it'll cross at 0. Where n is an integer. When you find these values, you are solving the equation. On the other hand, an equation that is true for all real values in the domain of the variable is an identity. For example, the familiar equation sine squared x equals 1 minus cosine squared x is true for all real numbers x, so it is an identity. Again, and that's because it equals 1. Sorry, y'all. All right. Verifying trig identities. Although there are similarities, verifying a trig equation is an identity is quite different from solving an equation. There is no well-defined set of rules to follow in verifying trig identities, and it's best to learn the process by practicing. So what this is saying is, it's kind of like geometry. The way some of you saw like solving a circle or solving a triangle might have been a little bit different than somebody else, okay? So this is going to be the same way. As long as you get the same end, the stuff in the middle is not a huge deal, okay, as long as it works out. So the first thing that you want to do is work with one side of the equation at a time. It's often better to work with the more complicated side. So what you want to do is pick the hard side, just like I said yesterday, find the hard stuff. Where's the hard stuff at? And minimize it down to like sine and cosine, so it's easier to work with. So you want to pick the complicated side, whichever one looks the worst, that's the one you want to start with, and minimize it down. Look for opportunities to factor an expression, add fractions, or square a binomial, or even create a monomial denominator. All of which you've done. We factored, we added, when you had the two fractions, we've added those, we squared the binomial, and then we have made a monomial denominator. Monomial means that there's only one term in the bottom. Look for opportunities to use some fundamental identities. Note which functions are in the final expression you want. So if we're working on the left side and we look at the right side and it's got sine and cosine, we want to make sure that we put it into terms of sine and cosine. That's just what it's going to say right here. Sines and cosines pair up well, as do secants and tangents. And cosecants and cotangents. And if you think about your trig identities, I'm gonna cover this up. I'll uncover it in a minute. Sine and cosine are together, tan and secant, and cotan and cosecant. So that's all it's saying, is they match up well together. If the preceding guidelines do not help, then try converting all items to sines. I'm sorry, all terms to sines and cosines. And always try something. Even making an attempt that leads to a dead end can prove insight. All right. Verify the identity that secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Which side is the hardest? Yeah. So the left one is the hardest one. So we're going to fix it. So we're going to write it down and we're going to try to make it look like this. So secant squared theta minus 1 over secant squared theta. Because you have a what? That minus 1. Now, if it were just this, yes, they would cancel out. If this also had a secant squared theta, we cancel all 3 of them out. We're gonna talk about it. So what's our problem with this? Well, just the fact that we have secant squareds, right? Because we need to look like sine. But think about, wait a minute. Just 1 second. Think about it. Does secant match up with sine? No. So we're going to figure out how to get like literally around the circle to get back to the middle. Like it's ridiculously crazy. So I would keep this 5-1, the front page of 5-1 handy for yourself. Does everybody understand that? If you don't have your 5-1 today, it's literally in the front of your book. It's just harder to find everything. Okay. So let's look at the front paper. What do you see? So we have this secant squared minus 1 right here, right? If I subtract 1 right here, what am I going to get? Tan squared. So we're going to change it. So we get tan squared theta over secant squared theta. What is tangent? Okay, so we're gonna write that. Sine theta over cosine theta. What is secant? One over cosine, and it's secant squared, so we're gonna do cosine squared. So everybody okay with that part? What are you seeing now? What are we shooting for? For sine squared, right? Do we have a sign of the problem there? Okay, do we divide fractions? No, what do we do? Flip and multiply. Sorry, these should be squares. Why should those be squares? Because it's tan squared, so that's my fault. We're gonna take that sine squared theta over cosine squared theta, and we're gonna flip to cosine squared theta over 1. And what do you notice? What are we left with? What did we want? Everybody see it? Any questions? This is more like what'll be on your test.
All current ninth graders last name.
You just
are-
have to work this till it gets to that.
Or that. All
What
current
it's
ninth
giving you
graders
is
last
an
name
input.
S. Please enter
You see what I'm
the
saying? So
area.
start
All
here,
current ninth graders last
finish
name
here.
S.
Okay, so look at the next one. What's your more complicated side? So we're gonna work this and simplify it until we get to where? 1. When we get to 1, we're done. Okay. All right. So sine squared theta plus cosine squared theta. It equals 1, right? Over cosine squared theta secant squared theta. What's the hard part now? Which part of it though? The secant. Remember, cosine's a simple one, right? It's good. Well, what is secant? So what we have, 1 over cosine times 1 over cosine. What do you say? Yeah, so this is a full fraction right here. The cosines will cancel out. What's it give you? 1 over 1, which is 1. They're not as hard as you make them out to be. You just got to pick out the hard stuff and make it simple. Look at your next one. Because your cosines cancel out. So this is the same thing as multiplying these left to right. Cosine over cosine is 1. Look at your next one. Which one's your hard side? Yeah, definitely the right side this time. So it doesn't matter which one it is. Just make sure that you pick the harder one. So how do we fix this? We just did this in our homework that I showed you. Cross multiply, right? We got to add fractions. Okay. We got to add fractions. So we're going to cross multiply. Ignore this. All this is telling you is, hey, this is where we want to finish. Okay. So ignore it until you get like each step. Okay. Did it look the same? Did it look like that? Nope. Got to keep going. Did it look like that? So 1 times 1 is 1 times sine A is, and that's alpha. It's not really A, but you can write A. It doesn't matter. 1 times 1 is 1 times negative sine alpha is still negative sine alpha. If you say A X, it's fine. Remember, I told you you can do that. On the bottom, what do we have to do? How do we multiply them though when we do squish them? The outsides, 1 times 1 is, sine times sine is. And it's minus. Tell me what happens. Sine's on the top, cancel out. You're left with 2. What's the hard part about this? The bottom, right? 1 minus sine squared alpha. I saw a 1 and a sine squared. What happens when I do 1 minus sine squared? Cosine squared. So this is 2 over cosine squared. What happens when cosine is on the bottom? I can rewrite it as secant. So 2 secant squared alpha. Now I'm exactly where I need to be. All right. What's the hard part on this one? It's the same problem, yeah. The right side, what do I do to it? Cross multiply, squish the bottoms together. 1 times 1 is 1 times cosine B. And that's beta, but I just said B. 1 times 1 is 1 times negative cosine. Negative cosine. On the bottom, all we have to do is multiply the front and the back. 1 times 1 is minus cosine squared. What happens on the top? Look at this bottom. We're going to do it all at the same time. If I have 1 and I subtract cosine squared, what am I going to have? Sine squared. So on the top, 1 plus 1 is 2. On the bottom, I know I'm going to have sine squared. And then what is sine on the bottom? That's it. So on the next page, this next box is just a manipulation of the trig function, like the Pythagorean identities. So it's the same thing that we've already been doing in our head, but it's just wrote down for you. So in one of the previous examples, you needed to write the Pythagorean identity of sine squared u plus cosine squared u equals 1 in the equivalent form. So if I solve for cosine, what am I going to do? If I solve for cosine, I want cosine by itself. Subtract sine. We already did this. When verifying identities, you might find it useful to write the Pythagorean identities in one of these equivalent forms. So our first one is the one that we just did. Sine squared u plus cosine squared u equals 1. The other one that we have on the front page is 1 plus tan squared u equals secant squared u. And then 1 plus cotan squared u equals cosecant squared u. So those are from the front page of 5.1. Okay. The only reason we have these other boxes is now they're going to manipulate it. Yep. So on the first one, sorry, I'm gonna wait till I get that wrote down. Sorry, not trying to push. I just want to make sure you have time to do your homework. So everybody got these 3 wrote down. All right. So on the first one, if I solve for sine squared u, so I want to get sine squared u by itself, what do I do? So take 1 and take away cosine squared u. At the top, we already solved for cosine squared u, which was 1 minus sine squared u. So the main box solved for 1, so it said equal to 1. The second box solved for sine, and the third box solved for cosine. So that's all 3 of them manipulated by themselves. So any variation of that, you're going to use that trig identity. What about this one? This one is solved for secant. So now what if I want to solve it for tangent? Subtract the 1. Be careful about that. Secant squared u minus 1. What if I wanted to solve it for 1? Minus tan squared u. And that's all we're doing in this box is manipulating those trig functions, those trig identities. Is solve for cosecant squared. Let's solve for cotan squared. I want cotan by itself. Minus the 1, so cosecant squared u minus 1. And then in the next box, I want to solve for 1. So how do I do that? That's it. So again, we're just rearranging the equation. Verify the identity, tan squared x plus 1, cosine squared x minus 1 equals negative tan squared x. What's the hard side? How do we fix it? What is tan squared x plus 1? Right here, tan squared x plus 1 is secant squared. What about cosine squared x minus 1? Sine squared. Is it sine squared? Is it? Is it sine squared x? Look at it one more time. Cosine squared x minus 1. What did we have? One, we had it opposite. So what do we do to make it flip around? What is it? We talked about this yesterday. What do I do to make it? Put a negative. So we're just going to throw a negative right here. Why did that negative do that? Because we had to flip 1 minus cosine squared x. Does everybody understand that? What's the hard part about this one? What's the harder function? How do I fix secant? What is secant? 1 over cosine squared x times sine squared x. If we multiply these together, be the same thing as sine over 1. What do we have on the top? What else do we have out here? A negative. 1 times sine squared x is sine squared x. On the bottom, cosine squared x times 1. What is sine over cosine? Tan, and it's tan squared x. That's it. We're gonna do the same thing. We're gonna do the same thing. So look, the same way that we just did this, we're gonna do the next example. All right. The hard side is the left side. Do I have a trig identity that's secant squared x minus 1? We have that perfectly. Secant squared x minus 1 is tan squared x. Do we have one that is sine squared x minus 1? Right, so it's flipped around, right? So we got to fix it. If you want to go ahead and put the negative right here, so you know that's what it comes from, that's fine as well. Which one is the harder of the two functions? Tangent. What can we rewrite tangent as? No. We want to get to sine, so we got to have. We have sine. Yep, sine squared over cosine squared times negative cosine squared over 1. What happens? On the top, we have a sine squared x and a negative. So negative sine squared x. Most of them are only going to be a couple steps. If you're doing tons and tons and tons of work, it's probably a no. Okay, so be careful. Would you eventually get there if you would have done tan as 1 over cotan? Yes, because then you have to rewrite cotan. All right, next one. What about this one? We could. I did the last time. Why would I do the last time? Just because they're added together. It's two different terms that I squish into one. Does everybody understand? It's a little more expanded. So I want to be able to squish it in. Could you go from the right side to the left side? Sure. Okay, it's going to be a little bit harder. So always do this one because it's a couple different terms. What is tangent? What is cotan? Think about it in terms of this. Cosine over sine, right? I need to get these put together. How do I put them together? Cross multiply, squish the bottoms. Sin x times sin x plus cosine x times cosine x. On the bottom, what am I going to have? Tell me what you know. What's the hard part? Yeah, what is the top? It's equal to 1. Yep, our trig identities, Pythagorean identities say that sine squared x plus cosine squared x is 1. If you can already see this, we're at our answer. Why? What is secant? You see it in there, 1 over cosine. What is cosecant? 1 over sine. So literally, you can split these up like this. And that's what's going to give you secant x, cosecant x. The next one is the same exact way. I set this up like this on purpose, okay? So we're going to work it the same way. The only difference is this is subtraction. We want to work with the 2 terms to get them narrowed down to 1. So the 2 terms are harder, or pick that side over the other one. So what is cosecant? 1 over sine. We're going to subtract sin x. We can leave it as sin x over 1. Why didn't I change it? There's nothing to change it to. We're not going to be able to fix it. How do I get a common denominator to push them together? Cross multiply, right? 1 times 1 is minus sine times sine is. On the bottom, what am I going to have? Just sine x. You see anything happening? What? Which one's the hard part? One of them does not get. Why can't y'all understand this? I told you 40 times. 1 minus sine squared x to cancel anything else has to look exactly the same. Yes, yes, these are together. These are a couple. Johnny cannot break up the couple. Does everybody understand that? Can't break them up. Does everybody understand that?
Yes.
Now, if Johnny was in all 3 of them, Johnny could pull out. Does everybody understand that? Don't, Sarah. Is everybody good? Does everybody understand? Okay, you've got to have all 3 of them containing that sign before you can eliminate a sign. Why is it cosine? Guys, stop. Can we please be adults? You're fine. So the top is one of those Pythagorean identities, cosine squared x. What are we trying to get to? What is cotan? So technically, I have a cosine and then a cosine over sine.
Yes.
You see it? You can split this up. like this so that you can see it. That turns it into cosine x, cotan x. Because cosine over sine is cotan. Alright. Recall that rationalizing the denominator, which we have been doing with the square roots, using conjugates, we did all day yesterday and within our homework today, is a powerful simplification technique. A related form of this technique works for simplifying trig expressions as well. For instance, to simplify 1 over 1 minus cosine x, multiply the numerator and the denominator by 1 plus cosine x. We've already done this. So we're going to write that out now. On the top, you'll distribute the 1, and on the bottom, it's just the outsides. So what am I going to have on the top? Nope. Just cosine. 1 times 1 is 1. 1 times cosine is cosine. On the bottom, 1 times 1 is negative times a positive makes a negative. Cosine times cosine is cosine squared. You can keep simplifying this. There's a trig identity on the bottom. What is 1 minus cosine squared x? So we have 1 plus cosine x over sine squared x. We can split this up just like we did the other ones, where we have 1 over sine squared x times 1 plus cosine x. You can do it over 1 if you'd like. What is 1 over sine? And all this did was keep us from having a denominator. Ask the question, what?
I was gonna say a lot easier other denominator being sine x, the other one which is just move the-
Yes. And there was only one of them, so it just hangs out there. All right, so the expression cosecant squared x times 1 plus cosine x is considered a simplified form of 1 over 1 minus cosine x, because what did I just tell you? Cosecant squared x and 1 plus cosine x don't have it's not a fraction, sorry. So it's considered simplified when it doesn't have a fraction, and that's what we want to do. Four more examples, sorry. All right. Which one's the harder side? Can you do either one? Sure. The one that I chose to do was the right side. Why? It's a fraction. Okay, so let's fix it. How do I fix it? No, the 1 minus sine x doesn't equal to something because it's not squared. Okay, so how can I make it squared though? And don't say I can square it because that's not right. How do I fix a fraction? Conjugate. That's key was that we just talked about conjugate. 1 plus sine x over 1 plus sine x. Distribute on the top. What am I going to have? And it doesn't matter which order you write them in, if you write cosine x and sine x. On the bottom, 1 minus sine squared x. What is 1 minus sine squared x? So the top is good right now. The bottom turns into cosine squared x. Here's what I'm talking about. Look at all three of your terms. What do they all have? Because they all three have cosine x, now we can cancel it out. Does everybody understand that? If there was a 1 up there, we can do this. Yes, because how many are on the bottom? There's 2 on the bottom. There's 1 in each one, so I can cancel out 1 in each term. So if I cancel out 1, what's cosine over cosine? 1. Sine cosine over cosine is just sine. Don't think about it too much. If I took out the cosine x right here, it would leave me with 1 plus sine x. Everybody understand what I'm saying? Over cosine squared x, and that would cancel out one of them. So you're left 1 plus sine x over cosine x. Addition in the top of a fraction is good. So, or subtraction, because then we can split the fraction up. The way we can split it up is 1 over cosine plus sine over cosine. So each term over its own denominator. What's 1 over cosine? Sine over cosine? Check out your left side. All right, thank you. Just grab the homework from somebody. And remember, I'm recording so you can get the last 3 problems. I'll send it to you. All right, so what do you think we should do on the next one? It's the same problem, right? Same problem. So multiply by what? What do I get on the top? Distribute your sine x. Sine x plus sine x cosine x. Again, you can have cosine x, sine x. It doesn't matter the order, it's multiplication. The outside's 1 times 1 is negative cosine times cosine. What about that bottom? It's going to turn into sine. I'm going to go ahead and take my sines out of the top as well. So I factored out a sine. Turn this into sine squared x. What's going to happen? One of the sines will cancel out. You're left with 1 plus cosine x over sine x. It's good when you have addition in the top. You don't have to fix it. You can split it. So what are my 2 fractions? What's my first one? 1 over sine x plus my second one is cosine x over sine x. What is 1 over sine? Cosine over sine? Cosine. Looks just like the other side. All right, so now if you look at the next ones, one side is just as bad as the other. Everybody understand that? One side is just as bad as the other. You can work with each side separately and make them look the same. So we're going to start with this side. So cotan squared theta over 1 minus cosecant theta. Say it again. I can't hear anything. Oh, plus, sorry. Go ahead. Is there anything I can fix there?
So 1 plus cosecant would not equal cosine.
Is it squared? No, so we can't work with that one. That one's good. So it has to be the top that we work with. What can we turn cotan squared theta into? That trig identity, Pythagorean identity, cosecant squared theta minus 1. All right, are you ready? Still working with the top. What is something else I could do the top? And I'm not trying to take it backwards. Hayden. What can I do? We did it yesterday. What if I had this? What could I do? I can do what to it? X minus 1 and X plus 1, right? So I can factor it. If you have to put that there, go ahead and put that there. So I actually get cosecant theta plus 1, cosecant theta minus 1 over 1 plus cosecant theta. What do you notice? These two cancel out, right? Because I can rewrite them the other way. Can I do anything else right here? Remember, it's in simplest form when it's not a what? Fraction. So as good as it gets. Now, it doesn't look like the other side because the other side is a fraction. How do I fix it? If it's add or subtract on the top, that's good. We don't have to do a lot of work. What can we do when it's add or subtract on the top? Say it again. I can't hear over all the coughing and the split it up into what? 1 over sine theta and minus sine theta over sine theta. What is 1 over sine? Cosecant. What is sine over sine? Look at these two. So make them look the same. One more. It doesn't matter which side you start with. This side is the harder side. Okay. So we're going to do tan squared theta over 1 plus secant theta. Do the same thing we did on the last one. What was the first thing that we looked for? What's the first thing we fixed? The top. So tan squared theta can turn into what? Secant squared theta minus 1 over 1 plus secant theta. Then what did I do to the top? I factored it, right? So what did I factor it into? Doesn't matter which order you put it in. On the bottom, 1 plus secant theta. What do you see? No longer a fraction. So I've simplified this as much as I can. Go to the other side. It's addition or subtraction in the top, which means that's good. What can I do to it? Split it into 1 over cosine theta minus cosine theta over cosine theta. What's 1 over cosine? What's cosine over cosine? These two are the same. I didn't go anywhere. I didn't do anything. Sorry, I lied. We have 2 more examples. I thought that was my homework. These are easier than the ones we just did. They're really quick. Y'all good? All right, verify each identity. Tan to the 4th x equals tan squared x, secant squared x minus tan squared x. What do you notice? This is the hard side because there's a lot going on. What do you notice about both of them? Take out a tan squared x. Lisa, where? Come on, guys. Secant squared x minus 1. What is secant squared x minus 1? What is it? Tan squared x. What is tan squared times tan squared? X squared times x squared is x to the 4. That's it. When I told you it was quick, I was serious. They're really, really quick. What about this one? Yeah, definitely the right side's harder. What do you notice? There's two cotangents in the parentheses, right? One in each term. So leave this cosecant squared x alone. Pull out a cotan x, which leaves 1 plus cotan squared x. So all I did was factor this. I pulled out a cotan x, and you're left with 1 plus cotan squared x, like that. Did everybody see what I did? And I just left this cosecant on the front. All right. What else? Mhm. This one changes to cosecant squared x. Now what can I do? Cosecant squared times cosecant squared is x squared times x squared is x to the fourth. There's your cosecant x to the fourth. And what comes next? Cotan x. That's it. 5.2, page 362, 10, 350. Every other even. Every other even. And again, we'll do the same thing. So if you get stuck, don't stress out. This will happen a lot this unit. So we'll go over your homework tomorrow, first thing, and then we'll do our notes. And then I don't know what the plan for you is on Friday. It depends on what we get done tomorrow.